Good evening, Advanced Math. Back to the coordinate plane a little bit today. Going to make some polygons on the coordinate plane. So give yourself plenty of space. Coordinate plane stuff tends to take up a lot of space. Make this your next title. Unpause when you're all ready and think with me. So when it came to polygons, we spent a lot of time on our polygons figuring out how to find their area. I want to give you a quick recap on some ways we found area. Where convenient, we used a method called tiling, which was where they would just, particularly on like rectangles, just tile it into unit squares and count the number of unit squares. That was probably the easiest method. Sometimes we couldn't do that though, because if you try to tile, say that, excuse me, these angled pieces wouldn't come out right. So our second area was, our second strategy was sort of a cut and move strategy, where we talked about like cutting this piece off and moving it over there, and that way it made a rectangle, and then we could tile it. There were also ones where we just kind of cut and add. So, to take, like a lot of times with trapezoids we would do that. And say with that, I could cut that into two figures and find that area and find that area and add them together. Sometimes we doubled. And so, for instance, a triangle like this was too hard to tile, but we could double it and do a rectangle, and then find the area of the rectangle, and then divide it by 2. And then last but not least, a lot of times we just used a formula. We had 2 formulas we learned. We had area is base times height. That worked for rectangles, and parallelograms. And then we also had base times height divided by 2, and that worked for triangles. So we talked about area for a long time. We had all those different strategies. And area is going to come up as we're talking about polygons a little bit today. So I just thought that'd be a good time to give you a reminder about how all that worked. Okay, so let's look at an example like this one. This says, find the area of a rectangle that contains these 4 vertices. In geometry, a vertex is like a corner. So let me make a grid here. Let's see, I think that's in here. Cool. There we go. And let's see, 9, -1, 9, 8. Looks like a lot. All I have positive x coordinates in almost all of my points there, so I may make kind of a lopsided coordinate plane here, because it looks like a lot of my points I'm going to go 9, 9, 3, 3. So they're all going to actually be over on this side in the positive x. And then a lot of them are going to go up pretty far on the y and only down a little. So I'm actually going to make my plane more like that. I'm not going to make it symmetrical in all my quadrants. So it looks like I'm going to be kind of over here a lot and not really over here in quadrants 2 and 3. I doubt I'm going to use those. So there's my plane, x, y. And so find the area of a rectangle that contains these vertices. So I'm going to start by putting those vertices out so I can see them. So I'm going to go 9, -1, 1, 2, 3, 4, 5, 6, 7, 8, 9, -1. There's the first one. Then 9, 8. 1, 2, 3, 4, 5, 6, 7, 8. 3, -1. 1, 2, 3, -1. And 3, 1, 2, 3, 4, 5, 6, 7, 8. So there are my vertices. So it says find the area of the rectangle that contains those vertices. So now that I've put those there, I can kind of see where my rectangle would be. Vertex, vertex. Sides connect vertices. A vertex is like a corner. Vertices is plural for, one vertex, 4 vertices. And so here is my rectangle. And pretty easy to find the area of that rectangle, actually. 2 different fast ways I could do it. It's all the coordinate plane if you use graph paper. I know a lot of times you guys just do it on plain paper and kind of do these kind of things. If it's on graph paper, it's already tiled for you. So tiling is going to be an easy strategy. It looks like it's 1, 2, 3, 4, 5, 6 this way. Excuse me. So 6, 12, 18, 24, 30, 36, 42, 48, 54. So it looks like I just count 54 square units. That was pretty easy. I also could use the formula area equals base times height. Remember, the base is like the side it's sitting on. So that's 1, 2, 3. 1, 2, 3, 4, 5, 6. And the height is 1, 2, 3, 5, 6, 7, 8, 9 units high. Remember, when I count those, I'm going in units, right? So this is the start, so that's 1 from this part of the grid to this. 1, 2, 3, 4, 5, 6. I'm not counting dots. I'm counting like line units, linear units. So base times height is 6 times 9 is 54 square units. So that's just an example of a problem you might run into on the coordinate plane. Combining. Excuse me for all this coughing. I'm going to pause real quick. All right, I think I'm better. So combining the coordinate plane and polygons. All right. So open your notebook. Let's try another one together. How about this? So look at the coordinate grid below. Points R and S will be added to the grid to form a rectangle with an area of 20 square units. What ordered pairs could be the coordinates of points R and S? So I've got to add, somewhere on here, I've got to add an R and an S. So points R and S will be added to the grid to make a rectangle. So obviously that's not where they're going to go. But I've got to put those in places where there will be a rectangle with an area of 20 square units. So like, for example, I could put them here and here, R and S, and that would make a rectangle. But that would not nearly be 20 square units. That would be 4 square units. So I need to make a bigger rectangle than that. If I put them here, that would make a rectangle with 8 square units, still too small. If I put them here, it's a rectangle with 12 square units, 4 more 16, so it looks like I could put them there. If I put R and S there, let's make sure I would have a rectangle. It's not a very good rectangle. Up, over, down. And let's make sure that's 4, 8, 12, 16, 20 square units. So that's a very good possibility. So I could put R at 1, 7, and S at 5, 7. Now, that's actually not the only possible answer here. That's a good answer. I made a rectangle and does have an area of 20 square units. But I could also make the same rectangle but down below as well. Let's see. What if I'm going to eyeball it? What if they were there? Would that give me 20? Or would that need to be a little lower? 4, 8, 12, 16, 20. Yeah, that would do it too. So I could also put R and S here at 1, -3. And 5, -3. And also get a rectangle with an area of 20 square units. All right, So that's just 2 examples of problems you might see involving a polygon in the coordinate plane. There are lots more, and we'll look at a couple more tomorrow. I think these 2 examples give you a good head start just in how to think about area and polygons in the coordinate plane altogether. If you need to go back and watch either example again, please do. But once you feel like you have a good handle on it and you have written this one down neatly in your notes, you're all set. See you tomorrow.